Okay, good morning. Today we will start with the Fourier transform part. Before that, let f of x be any function, then Fourier transform of f of x is defined by f of x 1 by root 2 by integral over minus infinity to plus infinity f of x e power I s x into dx. This is the Fourier transform of given any function f of x. Then the inverse function f of x is equal to 1 divided by root 2 pi integral over minus infinity to plus infinity capital F of s into e power minus I s x into dx. This is equation 1 and 2. So together equation 1 and 2 called as Fourier transform path. Together equation 1 and 2 called as Fourier transform path. So next we will discuss about properties of Fourier transform. So first property, linear property. So the linear property is nothing but if a and b be any real numbers, then Fourier transform of a into f of x plus b into g of x can be written as a into Fourier transform of f of x plus b into Fourier transform of g of x. So we know that Fourier transform of f of x 1 by root 2 by integral over minus infinity to plus infinity f of x e power I s x into dx. So here our f of x is nothing but a into f of x plus b into g of x. So instead of f of x, substitute the function. So 1 divided by root 2 pi integral over minus infinity to plus infinity. So instead of f of x, our function is a into f of x plus b into g of x e power I s x into dx. So next we split the two terms, right? So 1 divided by root 2 pi integral over minus infinity to plus infinity. So first term is a into f of x into e power I s x into dx plus integral over minus infinity to plus infinity b into g of x e power I s x into dx. Right? So next, take the constant term outside from the integration. So we will get a into integral over minus infinity to plus infinity f of x into e power I s x dx. And here take b outside. G of x into e power I s x into dx. Okay. So this is nothing but integral over minus infinity to plus infinity f of x e power I s x into 1 by root 2 pi is nothing but Fourier transform of f of x plus b into this is nothing but 1 divided by root 2 pi g of x e power I s x into dx Fourier transform of g of x. So hence we have Fourier transform of a into f of x plus g into f of x will be equal to a into Fourier transform of f of x plus b into Fourier transform of g of x. So next property, shifting property, Fourier transform of f of x minus a is equal to e power I a s into f of x. We know that Fourier transform of f of x equals 1 by root 2 pi integral f of x into e power I s x into dx. So instead of f of x, substitute our function f of x minus a. So 1 divided by root 2 pi integral. So instead of f of x minus a into e power I s x into dx. So here we are going to use a substitution method. So let us take t is equal to x minus e. Right? So from this, x is nothing but t plus e. Now dx is nothing but dt. So substitute these values of the integration. So we will get 1 divided by root 2 plus infinity. F of x minus a is nothing but t. So f of t and e power I s. So instead of x, substitute t plus a. T plus a into dx is nothing but dt. Clearly 1 divided by root 2 by 6 is nothing but e power I s into t plus a is nothing but Fourier transform of 2 pi integral over minus infinity to plus infinity f of t. Just split the terms e power I s t into e power I s a into dt. So e power I s a is nothing but constant. So take out from the integration. So we will get e power I s a into 1 divided by root 2 by integral minus infinity to plus infinity f of t and e power I s t into dt. So this will be equal to, this is nothing but 1 divided by root 2 by integral f of t e power I s t is nothing but f of s. So e power I s a into f of s. So clearly shifting property is nothing but Fourier transform of f of x minus a will be equal to e power I a s into f of s. Thank you.